good evening, guys. Like Matt said, I'm Tim Marcinowski. Some people know me as Tim Ski. I'm going over a broad range of technologies, and you're going to ask yourself as I'm going through why I'm using so many different technologies. And I'll explain the political reason behind it, which might help out your DevOps shops if you're working in an enterprise or a larger company or organization. So before I get started, I'm going to name off a couple of topics I'm going to talk about, and I want to see what you guys want to hear more about particularly that I'm going to talk about this stack and flow. So I'm going to talk about FPM, the Ruby gem for building dev files and RPMs. So if you raise your hand, just show me if you're really interested in FPM related stuff. Okay. I'm going to be doing Jenkins, some Jenkins stuff. That nobody use Jenkins anymore. All right. Talking about Terraform. A little bit about Fabric, not really much. Going to be doing a lot of AWS stuff. No matter what I do, it's going to be in AWS. You're welcome to ask me questions. I'll try my best to answer you. And then, of course, there's a Flask app. I can kind of briefly talk about Flask, the Python microframework. Yeah. So cool. So quick introduction. I'm a dev at the FINRA. The picture here in the lower right part is a little blurry, but basically it's showing the number of transactions FINRA take in every day. And you can see some big names up there: Facebook, Twitter, Visa, PayPal. FINRA basically regulates 90% of all exchanges, NASDAQ and New York Stock Exchange. So we're a big data warehouse. We have a lot of web apps. Primarily a Java shop. I'm an awkward Python guy, so you know how it really is. So getting in here, we're going to go over current architecture, what we're doing today, and then we're going to go into future architecture. And I'll kind of explain why I went this route to begin with, and why I didn't go for that perfect architecture infrastructure in the beginning. And it's really where that DevOps part comes in. So basically, we're getting SVN shop. We're taking our code into our build. Then we pull it, building the RPM via Docker, and then after that RPM is built, it gets posted into my open source project, yum-nginx-api, and then a test gets kicked off in an EC2 instance, and then of course a job gets triggered to promote the repo. So you'll see how that build goes, and what I did for devs to kind of get some tool adoption. Using FPM, because sometimes in a large organization, not every dev wants to go after the latest and greatest tools and learn all the new bells and whistles. So you got to do some legwork if you want to get things in-house in a large company or enterprise. So FPM, the FPM Package Manager, as you can see, there's the GitHub URL. Now these use cases are more defined towards my use cases, only because this is what I mainly use it for. But if you've ever built an RPM or you ever built a dev file, sometimes spec-files or RPMBUILD can be a real pain. And FPM kind of takes that away from you, extracts that from your daily workflow, especially if you want to not deploy tarballs or zip files. And another question related to that is there anybody in here that doesn't understand why you want to employ an RPM over a tarball or zip file? I think my story on the meetup page kind of went over that, and it's probably why you're here is because you're like, wow, I kind of understood where he's coming from. Is there anybody in here that doesn't understand why you want to use an actual package manager to deploy or distribute things across your infrastructure or platforms? Right, it's pretty cool. Simple ones is you want to package up libraries, middleware components like Tomcat, Nginx, Apache. Those can be custom ones, like for example, our Apache and Tomcat is from SpringSource, and our Zookeepers are from third-party vendors and Solars and those kinds of things. They're supported products, and sometimes they don't have packages, or sometimes you get the package from your vendor, the binaries or the files, and then they're not compliant in your environment. So one reason why you might want to build your RPM for these and not use vendor-provided packages is, for example, you want to have compliance already out of the box. You don't want to wait for it to get on the system and then comply using Puppet or Ansible or Chef. You want to build that package already compliant. It comes with a lot of the basic security rules. For example, if you're using the OWASP standards for rules for the Apache package, you can build those rules right into it, package it up. And this way your deployments get kind of quicker. You don't have to wait for Puppet to do all this magic stuff to get your code deployed or PHP stuff. files dropped. It mostly works great for binary files. Doesn't really work all that well if you want to do PHP. Sometimes it makes more sense not to make an RPM of PHP files or flat file kind of texts. You could do it. I'm not saying you can't. I'm just saying though that it goes mostly against doing binaries, or you want to have a lot of config files, or you have a big directory layout that you want to have package up and put it in somewhere. And of course, here's some examples. And I'm going to give you guys an awesome demo of end-to-end what happens with using all these different technologies. But here's a basic, Tomcat RPM. You go to the Tomcat website and you get the latest Tomcat. And of course, you can use like software collections or something that may already have it. But like I said, this goes into you want to customize it, you want to get rid of default files, you want to add compliance, other layers onto it. So this way you minimize deployment time, and you're also maximizing like your security posture in your environment. So basically just pass command line arguments to FPM, which is, like I said, is a Ruby gem. So you can just gem install it. And then here's some two gotchas that I discovered while working with FPM quite a bit. Is the RPM auto directories is you normally want to use that except when you have like init files or some sbin files. Because what happens when you try to remove the RPM, it tries to remove some of those files, and you obviously remove sbin, you can't like shut down, and there's some other critical files in there, your init files. They'll throw some errors. If you're using Red Hat Satellite Server, sometimes when you build the RPM to FPM and you're trying to upload it, you might ask yourself like, why isn't this working? Something happened during the build. I guess maybe the generic spec file in the background doesn't apply something that Satellite Server requires. I don't really know, figure it out. Most of the stuff I write is all custom. Trying to get away from the Red Hat licensing and pricing. And then interesting, Docker's weekly newsletter last week came out with an interesting article about building RPMs within Docker container, which is really awesome. But then the guy noted in the blog post that once you build the RPM, it's just kind of sitting there, you archive it. It's like, how do you get it from your current build environment into like dev or into something else? You have to like SCP it, you have to do et cetera, and we'll go over to the next project, the yum-nginx-api, which kind of helps with that and how you can kind of customize it to meet your environment's requirements. Which I'll show you the Docker file. I'm actually going to switch over right now to my example Docker file to show you what I'm really doing. Yeah, so real plain, basically just adding in some proxies, installing some packages or groups, all the packages I need. And then I'm adding this RPM file, and I'll go over that here shortly. It's kind of what I did for devs to minimize that learning curve of FPM, or getting it really kind of just built really quickly without them needing to do anything. And then you start that SH, which it's just basically the script. So when you mount the data volume with the contents of the package or whatever you checked out from Git or SVN, you're going to mount that directly into the Docker data volume. And then basically within that directory, you're going to find out where your RPM config file is, which this is totally custom to our environment. It's not open source, but basically this RPM config is a config file that you specify, like the name of your package, version, pre, post install, conditions, an init file, like those kinds of things that will be needed for your RPM. And of course, building the package, and then after the build, posting it to the API for further processing and testing. And of course, basically, this is a really horrible Python script. But this is basically what it does is, basically just wrapping FPM within a bunch of conditions. Obviously, couldn't make them functions because they're just pretty complex conditions. And just kind of staging things for them, doing the build, removing temp files, and then, just like I said, cleaning up any kind of file. So it kind of takes some of that away from you, kind of standardizes your CM process, your build process. Especially when you want to standardize this across the enterprise, and you want to get most applications, or at least middleware components, built using the RPM package. So pretty much I showed you this. For the YUM repo management through Jenkins CI, I'll explain the future and why you should probably get away from Jenkins CI. This is more of like if you're a small shop and you're using Jenkins for everything, this makes a lot more sense to manage your repository using Jenkins, especially if you have more than one Yum repository. You might have multiple VPCs, multiple environments within one VPC. You might want to set up different repos for maybe different applications, whatever your needs may be. Basically, the rsync and create repo and repo sync are your best friends, especially if you're pulling from Ruby, the Red Hat infrastructure, update infrastructure, you're pulling from Pell, RPM Forge, Varnish, Nginx repository, Jenkins RPM, or Jenkins repositories, any of those kind of places. You want to use that repo sync if you never used it before. One of the things I really recommend is when you are building new RPMs and you're putting it in your repository, whether it's through the API or SCPing it over, you're going to have like that pre-release or beta channel or repository. So this way you're not contaminating the main repositories that they're using day in and day out. And those should not be enabled by default on your systems. So this way you can kind of isolate what you want to install in the system, depending if you're in a staging environment or a dev environment. Or of course, if you're testing your RPMs, which will show you the demo, kind of doing a promotion after the test complete from the beta channel over to your main repository, or one of your main repositories, depending on your environment. One cool thing I did, so if you basically don't have satellite server and you're just doing this all kind of custom, something cool that I do on the system, and I'll look at all this crazy stuff, right? I'm tracing this all. So something really cool I do with the system is I'm scraping the Reddit page from Red Hat, and I'm getting the latest update of Reddit patches that Red Hat gives you, and putting in a file on the system. So this way you can query your system, or you can make a Puppet fact, or some other kind of fact in whatever CM tool, and show you like what servers are patched up to what Reddit level. So when security experts come, or whoever may be coming, you can go to that system, you know what it's patched up to. So like when Shellshock came out, or Poodle, and you look at a Reddit, you can say, yeah, all these patches up to this are patched. Probably could have did this a lot better in Beautiful Soup, but did this like forever ago, right? So yeah, I built an RPM of it. So when I get that patch level, this way when I do a yum update on the system, it gets that new latest patch RPM. So this way that file gets written over to. So this way you keep track of your instances or your servers if you're not paying for like satellite, or you're registering things, or you're trying to look through your public console and see what packages are installed, what versions on what systems, or you're making fabric scripts or func scripts or whatever you have internally. So that's kind of like one of those cool things I think I want to share with you, especially if you're wanting to manage all your servers and kind of know the state of compliance on them. So cool. So this is where the prompt came when I was building all these RPMs. I didn't know what to do with them. And what better way but to create a Python web Flask application to just basically make an upload RPM URL string that I can basically do the build and then post to my repository directly. As you can see here, the workflow. So I put the engineer here because to gain adoption in the enterprise, sometimes you don't always start out with the CI first. It's usually like you're doing backup boxes, you're doing things locally, and then eventually get into a CI environment. So I told all the engineers and developers, I said, hey, listen, you can do this too. Following this method, you can go on a Vagrant box, build your RPM, and then post it, and the tests and everything get taken care of for you. And they don't have to create Jenkins jobs, they don't have to do whatever, everything's taken care of for them. And that's how it should be for devs, right? Devs for dev. That's what it's all about. And then basically you see this pull put Jenkins part. This is more like for promotions. If you want to go from your pre-release repository to your main repository, you want to go from this repository to your QA repository. Obviously with Jenkins, orchestrate that. And later in the slide I'll talk about Rundeck and why you should probably use Rundeck instead. So before going any further, is there any questions? I think we're about halfway through on any of the technologies. Maybe you think I shouldn't do something this way, maybe it's insecure. I don't know, any comments? Yes?
I just have a question about the Flask application.
Yeah.
Are you just doing that to provide an API to dump it as opposed to using like curl to push it to wherever you want to put it?
So I mean, you can use curl, you can use Python requests, you can use URL 3lib. You can use any of those to post the API. The reason why we have the API, so like this way, like a lot of times as CM engineers, we typically take an artifact and then we SCP it over to a file storage place or to S3 or to here or there, and then you have this text file and this tarball and it has a version, et cetera, et cetera. So this API is just more of like when you post to it, it adds it to the directory where your repository is at and then creates the repo for you. And then you can have a series of tasks happen afterwards. You can customize it to do whatever. As I'm going to show you in the demo, it's going to run like 2 or 3 tests, more like functional tests. You can add security tests to do like malware, blacklisting, all those kinds of neat things if you really want to. But that way, when you're talking to a developer and you mention API, they automatically know what you're talking about, right? Now you say you need to SCP this to this file and you have to get a key from IAM. And then you have to go knock on this guy's door with this sheet and do all this stuff. I mean, it kind of provides that quick and dirty interface. And with the API, you can provide token access if you want, or basic auth, or you can probably tie it back into LDAP, which, whatever. So, any more questions? Yeah?
Have you looked at any other applications, Mr. Nginx?
There was like 1 or 2 open source products. Honestly, one was like a Java Tomcat application. Kind of didn't really like that. Kind of want to do a little more custom. And to be honest, if you look at the code, the Flask app, if you take out the other URLs and you just look at the upload, it literally is like 5 lines of code. And I mean, that's what all I needed. I mean, you could have like reports generate or something else happen, but for pure like quick functionality, it literally took like 10 lines tops to write it. And most of it I copied from some tutorial and like did some other fancy things with it. And getting Nginx set up was pretty cool. So if you ever had to set up a repo and you kind of want the fastest downloads and that kind of thing, you go with Nginx. And the example within this repo is pretty awesome when you're serving the RPM binary files statically from Nginx, which is typically faster than Apache, or if you're going to run like Python simple HTTP server or whatever you're running in your infrastructure. Yeah.
So there's a post, so you can do something. Did you also have like GET requests where you can find out like what happened or the status? And are there any like webhooks that'll tell you, hey, this is done running, like you can go check it now?
Yeah. So so explain why we're going to tie more Jenkins in the future architecture. But you could get a GET listing of the repository, which is pretty cool. It's a pretty cool feature. It's a little buggy, but basically when you do a GET request on API repo, it will list all of the packages and versions and some other information too, which is pretty cool. I think I have the example on the wiki. I have a whole bunch of examples on here in the wiki. Yeah, so basically here's what your successful and unsuccessful post will be when posting to it. Does a couple of checks, nothing real crazy until the tests. And then when you do the repo, it'll list like an RPM, or this one lists 2 RPMs to tell you the architecture, the summary, and the version. So that's also a verification. But I'll tell you why you want to go look at Jenkins, because after the test, you want to go into your metrics and all those kinds of things.
So Tim, how long does it take for the post to give a response then? Because it has to gather all this information.
You'll actually see that in the demo.
Okay.
Literally, it's quicker than if me actually going to look through the build log. It's probably already done by the time I go look at the build log. And that's because I'm using Nginx Screen Unicorn in the Flask app. And it runs pretty fast, and I'm posting anywhere between 10 to, I've tested up to about 800 megabytes for an upload. It's an Oracle client can sometimes be pretty beastly if you have all the plugins and stuff. Yeah.
I understand you do not use Sunlight,
Correct.
and I understand that your repositories are actually provided by your Nginx server, correct?
Correct.
Why did you try, or did you think using the pulp over an Nginx server?
Yeah. So, I mean, Pulp is used to, like Pulp. I mean, even a new Satellite server, you got Pulp, you got Puppet, you got all these tools baked into the Satellite server. That's basically what Satellite server is. Is all these open source components in the one large server, and you pay $10,000 for a license. But even if I use the open source Pulp, let me tell you some. To win with these security guys, there's a web interface. They're going to want to lock down with accounts and like tie it back into LDAP, all those things. it was easier for me to get buy-in having something custom development with no web GUI, and I can pull all this information in JSON and create a web UI if I want to on the side. It was quicker adoption, and it was more like one of those hurdles with security and those politics.
Up to 0, I think it doesn't have a user interface.
Oh, okay. Oh, I didn't
There's
know.
only a API.
Wow. Yeah.
It's a CLI, common based, and also REST. And yeah, other stuff.
Yeah. So, but like when you post a poll, how can you tie in like trigger to do a test or something? Is that pretty easy?
There's a Qubit or RPMBUILD event,
Yeah.
and you can tie to that, and you can also do the workflow. But tied into the CI, you also would like to use it. I mean, CI would be the one who consumes the events and say, I'll do that, I'll do that.
Yeah. Yeah, I mean, that's pretty nice. I mean, you're adding, your message broker onto it, and these other technologies too. I think this was definitely the quickest way. Like I said, 10 lines of code,
Sure.
tied already into Jenkins, quick adoption, getting over the hurdles with security, easy wins. Because even sometimes, some companies have an onboarding process of applications where they might be like, we want to introduce this open source product, and then they're like, well, what's their license? And then they're like, who's supporting this? Is this in some German basement? Like people ask these kind of questions in larger companies, and in a startup, I would definitely go with bulk all the way for sure. But sometimes you need to do some of these kind of things to get adoption. You really do, and especially if it's custom development, getting your hands dirty. Yeah.
Hey Tim, can you talk a little bit about going through the security process? Because is Python widely used at FINRA, or was that something that was like a one-off approval? How did that whole process go?
So it's improved being a dev library, but then when you start adding more libraries or third-party or open source things that use Python, then it's more like a governance board. You have to get approval. You have to sometimes give a demo. Then they come up with these undocumented requirement sheets that they just made 10 minutes before it that have like this long, and then you weren't prepared for it. So sometimes, like I said, going through that is painful. I know, like State Farm is a company just like that. They have processes just like that.
About this, do you use open internet to get all
Even if it's just a clan name vscan, the ones from Red Hat, obviously are signed, and we do the verifications, you do check. But for like ones that we customly build, they don't really have, they just have like a generic signature if I'm not mistaken. Could be a little wrong, but that's something we'll incorporate into it. As we get more adoption, we do this for about maybe like 6 different components or maybe 10 different components right now. Because as soon as we get more, we're going to build more into it. Because we want to add this as our pipeline. We want to use package managers, and we don't want to have floating around tarballs and zip files with version files in them. You can't query things, and those kinds of stuff. Any more questions? Cool. So Terraform Fabric, this will eventually in the future be replaced with Docker, but it's more of like, it's cooler to kind of show the demo because Terraform is a pretty new tool out there on the block. Same makers of Vagrant. Basically it's like CloudFormations but cloud agnostic. So if you're working in multiple cloud vendors, and you want to spin up instances or ELBs or VPCs, those kinds of capabilities, you want to use Terraform. So this way, if you go to Cloud B or whatever company gets invested with, people are familiar with syntax. It's not pure JSON, because sometimes JSON can be a beast of its own. And then Python Fabric's been pretty around. This is like a parallel SSH library or a tool that you can use to basically SSH to a bunch of boxes at one given time. It's going to be really good here. One also good use case, instead of using Terraform and Python Fabric and also Docker, you can also use Ansible for this too. Does it very well. It's kind of what it's built for, was cloud first and all that good stuff. But I kind of want to test out new tools, and I'll kind of explain more towards the end why I did that. So one of the gotchas was, so in our AMI building process, we're building these images, we don't have any users built into the image. So most of the time you go to the marketplace, you might get an image and it has EC2 user, it has root, it has Ubuntu, it has some kind of generic user. We strip that out in the AMI, and basically you get, you have centrally managed accounts on the system. And that gets put on through a CM tool like Puppet. So when the bootstrapping of the instance comes up, talks to Puppet, gets the credentials, gets all the accounts that should be on that system based on roles and profiles or role files. So one of the things that Terraform didn't do for me was it can't wait till the user is present to then go on and SAP and do some tasks on that system. That's where Fabric comes in. And even Fabric doesn't do that too. And I'll show you a quick little gist of how to do that using import the Paramiko library, which is used to build most of Fabric. So basically my nice little repository here is kind of the example to go through it. What a Terraform template looks like is pretty straightforward. You have your region, you have your AMI, you have your key pair, you have your security groups. You might have some tags. You might want to output it into the host file, which obviously is what this example is for. So you can run Fabric later. You can assign user data. Your typical like EC2 run instances, API kind of calls are in this template, and you have your credentials cited off in another file. So then this way, for app teams, you want to spread it across the enterprise. You want to keep credential files separated from this instance, TF being Terraform. So up here, this is like for just provisioning an instance with some of those conditions you may have, like tags to do some additional automation, the user data part to do setting host name or doing more automation triggers. And basically the fab file, regular Python Fabric file. The only thing cool about this one is I'm just importing Paramiko SSH library, and then I'm just kind of doing this right here. So what will happen is I'm basically waiting till the user is available on the system, and then I'm going to go and I'm going to execute whatever my task is, which is nice because if you're a shop that has users already built in, then it's like no worry, you can use the Terraform remote executor. You don't even need Fabric. But if you have a certain condition where you have to wait for the users to be provisioned on the system, here's the kind of like wait to do the task. And this is how I'm executing the test that you'll see in the demo. This goes back into why I'm using so many different technologies and why there's a current state and a future state. Now everything always gets better, but I did this on purpose. And this goes back to what Matt was saying with war, the troop with the boots on the ground. That's me, a large company, financial company, real tough. And how do I get through some of those hurdles? Sometimes when you're demoing something, people are just like, ooh or ah. And most chances they're going to ask you, what are you using? Or how did you do that? Is it magic? They always ask that question 9 times out of 10. And then you say, oh, I'm using this tool. And what happens next? And it starts spreading like wildfire, and then everybody wants to use this tool, especially in the dev community. They don't know about it. They don't keep up with the Twitter feeds, whatever. This is kind of a way to kind of sneak in some of those tools and to kind of demo, do little side demos, and kind of build these frameworks and systems and components tightly coupled together. So this way, demoing FPM, like I created that wrapper script. When demoing FPM, they don't want to learn, so I created like an overlay that kind of made it easier for them. And now, once you get a dev hooked on something, they're always going to ask the question, well, I want more, how do I do it? And then they'll go and read the docs, and then now they're FPM experts. So it's kind of like planting that seed, getting that adoption that you'll need on a larger company. Sometimes even smaller companies, if you don't have the swiftest devs that you want, right? So before I do the demo, is there any questions about like kind of what I did here to get certain tools and things in the door at a larger enterprise? No questions about my war swords? So anyway.
Let's have the wall.
Cool. So right here, I'm just going to do this long. Looks like an error, but it's actually not. All right. So basically the structure of this project, so I'll kind of go over Zookeeper. So this is already compiled, right? I don't need to compile. I don't need to really do a build. I just got to basically do a pull and then do an RPM build. So say like this was the layout of Zookeeper, right? This is great. If you create, this was more of a wrapper thing when I did with FPM. So this isn't something that comes with FPM, this is more custom, but to show you kind of how easy that kind of made it for people to build RPMs without really knowing all the command lines and all the options, kind of abstracted that. There's a directory called RPMBUILD. If you want, you don't have to have pre and post install conditions. Your RPM config, which is just, I'll show you what one looks like. And then this Zookeeper is the init file. That could be called anything, Zookeeper init or, but that's the init file. And you don't have to have those to build the RPMs, but of course, if you want to build automation, like for example, in this RPM, the post install will check and config the RPM on. So now you don't have to tell it to start up next time it boots, because sometimes you forget about that. It's built into RPM. Let me find an example. Yeah, so basically this is all I do for the user. Now, not all of these are mandatory. Basically, the version, directory, and name are mandatory. Everything else will automatically kind of fill in for the user and group. If you don't define one in your pre and post install script, it'll just assign root to be the ownership of the files, not to actually run it, just to own the files. So, those kinds of things, building that for the devs, so like this, they don't have to know all the strings, or when you look at all the FPM commands, it's like this long, and then you get kind of confused, especially if you've never done it before. This keeps it pretty straightforward. The only time you have to really explain it is like pre and post install. So when you install the RPM, there's something that happens before it gets installed, and then after it gets installed, there's something that happens after it gets installed. Pretty straightforward. And those commands are the before install and after install arguments for FPM. So when I build this, right now it's going to build in a Docker container. As you see, checked out, basically it ran my Docker instance, it built the RPM, and it gives you the string. Also, I print out the string, so if you want to take the string and run out a diagram box or a dev box, you can also take this and do it yourself. So it's kind of like one of those things, like how did you do that? It's kind of outputs that for you. And you can see the post here, like Matt said, this was 3 megabytes, and I posted relatively, like you don't want to click on the console, it's already done. And then you get your status 202 or 200, and then I'm basically removing the Docker instance after. I want to get rid of it. And of course, if you come over here, basically on the API, it gets posted right here. It gets created a repo, so it automatically processes, and then next is happening is it's kicking off a Terraform, choosing a Terraform instance template to kick off the instance. Basically, it echoed the IP address into a host file, and then basically right now what's happening is Fabric is going to go wait and do the authentic, like see when the user is available, and then eventually they could kick on the test. They'll SCP the file over, execute the test, grab the results back based on results, promote the RPMs over to the main repository if it passes the tests. Right now we only have like 3 functional tests. It's just like sometimes when you're building with FPM, packages will fail to install. Obviously, it'll fail to remove itself, and then of course it'll also fail to reinstall the package. So just some quick smoke tests to get them going. As you can see, here's the output of the Fabric run. I didn't say all I did was kick off the Jenkins build, Docker builds it, posts it to API, API is doing the test. And I'll go over in the future architecture what you want to do, what should be done better about this scenario. And all I'm doing is basically going to the repository, downloading all RPMs that are in that beta repository, and then running the tests on every single RPM that's in the repository. Whatever ones are failed are not going to be promoted, and ones that are passed are going to be promoted into the main repository. So yeah, so the failed result came back, and then destroying the instance, right? So yeah, you can write this all in Boto or whatever, but Terraform kind of tracks all that stuff for you. So when you create the instance or remove the instance, or you change the alter state of the instance, you're keeping track of that state of the instance, and it's all in these secret files. Keeps track of like if it shut down, if it has this tag, if it has that tag, if it has this security group. What happens if you change, say X security group spec, say you change AMI, it's going to tear it down and we bring it back up. If you change the security group, it's going to add the security group onto it. And then remove the security group. So it does a lot of free, so you don't have to really script all that stuff. Now that's like if you have, now this is creating a brand new EC2 instance, it's running the tests, you know, right here I'm building the repository, it's all good to go, it's in the repository, it's been promoted, all the packages. Yeah, so that's basically using that end to end. And then one thing that doesn't happen here that would normally happen is there would be a Jenkins job trigger to actually promote the repository to QA, and then for staging production, VPCs. So, is there any questions on this particular process, or like why I went this way?
If you keep your Docker images, do you use your Nginx server or you use the hub?
So for the builds, I have them on Jenkins Slave. Is that what you're asking?
You have a Jenkins Slave to a box that has Docker.
So the Jenkins Slave has Docker on it with the image. Are you asking where I keep the image?
Yeah, you don't download the image.
Oh, so the image I trigger through another Jenkins job to go and put the builds. Like, so I don't have a hub, or I don't have a, you know, like a Docker hub. I don't have a local on a registry, right? I just kind of build them manually for each slave, because we only have 30 slaves or something. But eventually, when we become more Dockerized things, we'll set up our own private registry and do things like that. But right now, most of the Docker use cases we have is build test scenarios, not production, or even sometimes dev stuff.
How much do you have C++ to package it?
Not much. Most of it's Java. Some really small Python stuff. Yeah, there's really not much C++. But what your Jenkins job would look like is you would want to, you know, come do your compile. You probably want to test on that, and then you want to kick off a build, like an RPM build, and then promote it, you know, up or downstream or whatever.
What's being stored in SQLite specifically? Just metadata?
Yeah, it's just metadata on the packages.
How many workers are you running on Green Unicorn?
I have 4. I have 4 workers.
The only thing to be careful about with that is that SQLite's single connection at a time.
Yeah.
So if you have 2 API requests at the same time, one of them will fail.
Yeah.
So that's the only thing to watch about SQLite. So
Yeah, I think I mentioned in one of the previous slides is you probably want to have like a task queue.
yeah,
You want to have some kind of
That's
queuing
all.
system. And I'll explain in the future architecture why you kind of want to have a lot. Not have to be Jenkins because it has some of that. You know, it doesn't have to be Jenkins. It could be any CI tool. It has those queuing capabilities. You know, it has the logging capabilities. You have the test matrix that you can have for every test you run. So this way you're not having to ingest these logs into Graylog or Splunk or Elk or whatever, and then kind of looking through them. You have them all through Jenkins, and then you can scrape Jenkins and create reports. You know, do all kinds of crazy cool stuff. And what that looks like, going back to the slides. So basically this kind of looked like for the build and test. Kind of save money on the Terraform, creating a new instance. That was a cool thing like 2 years ago. But obviously since Docker will run really, really fast and you can keep on your slaves, you can have one slave and then many Docker hosts instead of having a fleet of slaves to do some of these builds depending on how large your build farm is. But this basically would look like, and then the promote repos in the earlier one, we showed that you had Jenkins promote those. If you're a larger shop, you want to go with something more like Rundeck. You want to keep some of the operations and the dev stuff kind of separate. So this way, like, people are like, especially enterprises, they're real afraid to give sysadmins access to Jenkins, or they're afraid to give devs access to Jenkins, or whatever it may be. Rundeck is just a job scheduling tool that you can go and you can trigger jobs to an API. Get scheduled jobs, you can go in there and push a button, get a OC guy or whatever to go push a button in Rundeck, whatever it may be. But that way you keep some of that stuff, some of that clutter out of the Jenkins stuff. You don't have to have all the Jenkins folders and all the jobs folders and all that stuff. But if you're a smaller shop, just like I said earlier, just do everything in Jenkins. It just makes sense. But if you have a lot of jobs, a lot of people working on things, you might want to keep it separated. And Rundeck is a good candidate to promote those repositories, and it has an API. So is there any questions about future architecture or anything I went over?
Except that you've had some problem with promoting the new RPMs to Red Hat Satellite.
Yeah.
Do you find that those RPMs do you guys have more than one type of Linux that you run, and do they work very well? Then like, do you guys do sound?
Are you a hacker? No.
No,
You don't look like a
But you know what I'm saying, like if you do like send-offs and other flavors, and do they work very well, or?
Yeah,
not
we
at
do, it's a very small send-offs footprint. We use mostly RHEL, and going to AWS with the whole unmanned licensing, we don't have to like register service to a satellite server anymore, which is great. But no, to answer your question, we do mainly just use Red Hat Enterprise Linux. And I mean, eventually we'll probably end up using CoreOS or something more modern.
So you said some problems you had with RPM packages and Red Hat Satellite, any problems that put in some spec file?
No, I think it's been a while since I looked at PM source code, but I think it generates a generic spec
Right.
for all the builds, and I think maybe something in that RPM spec doesn't work out well. I don't know. I didn't file an issue on GitHub. I filed like 6 issues. I felt pretty bad. I figured it can wait. It's not really that important. I don't know for any other reason why it wouldn't work. Maybe there's some metadata that wasn't put into it that maybe Red Hat requires. Maybe because it wasn't signed. That could be very well why. That makes a lot of sense.
So you moved away from Red Hat Satellite anyway, on the AWS.
Just for custom repositories. I mean, the create repo in a web server is pretty generic. I mean, some of the functionality you get out of the new Red Hat, the new satellite server, you don't really need like the puppet hooks and some of the other things they have, the bells and whistles they come out with. Like, yeah, that's great and all, but like, we really only just need to serve packages really well. I mean, that's the core foundation of it. And it kind of got diluted, just like most frameworks and systems. Yeah. And now, like, you can incorporate in your CI process. It's a lot easier. I've never worked with the satellite API. I heard it's not too hard, but at the same time, the Flask API was pretty straightforward. I just needed to get an RPM in there, and then something happened afterwards.
How long did it took to make all this?
The Flask app, I think it was like my first Flask app. I remember the second one. It literally took like 20 minutes tops.
Since when are you working on this?
Oh, when I've been working on this? November? Maybe October. I started working on it, or whenever it goes back to the open source stage, actually, I'll tell you right now. It's pretty much about the same exact time I open source did. So about 4 months ago is when I started this. And then I added the Jenkins jobs and the Docker stuff. The Docker stuff is pretty easy, but like I said, I had that overlay. Using FPM, it's actually like FPM strings to do things. I don't know how that look, but like you gotta kind of conform to the standard if you have a lot of, like for example, Fimmer has like over 150 different applications, right? And it's kind of, some of them Windows, mostly Linux, but like you kind of have to have a standard going forward with some of these applications and onboarding going into a new environment, into the cloud and stuff like that. So you kind of have to build that. I mean, if you don't, they're gonna stay in their legacy ways. They're gonna just keep with the tarballs and zips, and they're gonna be cool putting this stuff in S3 and just kind of worrying about high-end permissions in S3 and that's public, and you're gonna have a lot of that stuff. So in order for people, you build it and then they come, you gotta really build something great.
How did Finra feel about open sourcing the work? Just were there any?
That's a great question. I think after one time we open sourced something through legal, it got a lot easier. The first project was nobody in legal knew about the Apache licenses and all those other licenses, GPLs and stuff like that. That ones, we were basically green lighted to go with a lot of other open source stuff. If you look on the Finra repo, you'll see most of it is test stuff, really test heavy quality. I think we just did the Google test conference a couple months ago, and we're pretty test driven about everything. So yeah, I mean it's for a large company with as much data we have and compute and all that good stuff. There's a lot of cool work that goes on. Don't let me scare you away when I say security is all like this, and there's kind of go through this governance process. Sometimes you have to, especially you never know what everybody's going to do once you open up the gates, especially to AWS.
So once you started open sourcing, what was some of the biggest positives that you could use to go to security and business process types to sell open source and other projects?
I think it was more of like a, driven from the CIO that if you wanted to open source something, and it didn't show like business critical algorithms or like how we catch bad guys kind of things, you can pretty much open source it. And then, so I know that seems like a little long, but like our process, basically once you bring it to the open source board, it typically takes about 2 months to open source it. That's just kind of demoing and talking to architects, going over, making sure certain documentation and DCOs are in place, making sure that Finra is going to actually benefit from it. Like you're not just throwing some code up there and it's going to just sit there and not everything happen. I mean, it has to be something that people are going to want to use, or it solves a problem that people are going to see. And I hope I really outline this in the project. I mean, I think I do, but if not, I mean, pull requests are always welcome.
Do you have a IRC channel?
I wish I did. We are not allowed to use IRC. But I mean, I think there's plenty of content. There's some good stuff in the wiki, some examples on how to post RPM using Python requests. Which if you've never done that, that might be something, how to trigger Jenkins jobs. This might not work for every Jenkins version, but there's examples on there. Changing limits within it, adding authentication to it if you want to use basic auth. There's some good examples if you want to kind of add it onto yum-nginx-api. Like I did, the tests are not in here, but like if you wanted to add your own series of tests or you thought something could be better, then you could just easily take this and then plug it right in. Yeah.
Do you get any friction between using, after moving from satellite server and everything that comes with, going to something that's a little more open and potentially less secure?
There was some, not really secure because like most of the packages we get from are from Rui, and most of the packages that we build are either things that are internally developed or they are third part, like we pay for like Tomcat and Apache, right? And we build those custom RPMs. So they're coming from trusted sources. So it really wasn't that hesitant. It was more of like the reporting aspect. They just wanted to see like when things were getting updated and that kind of thing.
I was thinking from the other perspective, from opening, basically having an open repository where now you're publishing stuff and people can go and it's an easy API and you're talking about it a lot.
Yeah.
Whereas Ops seems to like have, we've got satellite server, it's pretty well locked down, only certain machines can talk to it, and so not everybody can come and just grab all our source code or our, our binaries anymore.
Yeah, it's a lot of massaging. You just gotta go out there and make people feel warm about it. It wasn't easy, right? But I'm surprised I don't have gray hair. But you just have to go out there and you have to be a good person. If you want something, you have to work for it. And that's what Miguel, my first lieutenant, and I did at Finra. What we keep doing, and I think it's a good thing when you get traction from the CIO and some of the other SVPs within the company, and they form a new team and ask you to come on board. It's really powerful because you get that high visibility. You get to change things and kind of like show people like this is how the new world works. If you have that backing from C-level up, then it's really not that bad.
Tim, so Docker is obviously a very talked about.
That's why I put in the meetup comment. I figured
Sure.
people want to come. If I put
Exactly.
Docker, people say
No,
Docker.
just,
People
if you
just
want
go.
to just
They're
add
like,
Docker to anything.
They're like, Docker, what's up? They're showing up.
I'm really curious
Pizza
on
Docker,
So-
Pizza Docker.
It's
Pizza Docker.
Taco Docker. Tacos Docker.
Yeah.
No, I'm curious. There's a lot of there's a lot of interesting stuff about Docker. There's also a lot of hype. As someone who's using it in your deployment pipeline, can you talk about your experience using it and just in general your feeling about the technology?
Yeah. So I'm sorry I couldn't demo an open source project that I started working on called Appetize, which was really cool. But I've worked with Docker really a lot over the past 6 months. And for simple application deployments like PHP or drop-in kind of file deployments, it's pretty awesome. Once you get a little more complex, it becomes like, this may not be it. But the biggest benefit I found it was definitely in the build test pipeline. Because this way we didn't have to spin up, so many clusters to do all this testing or slaves to do a lot of this workload. We just had Docker able to find the resources for those containers. And that's in my personal use, and that's on the job every day. That's where I got the most benefit from. Yep.
When using Docker, what's the normal way you guys handle environment-specific like configuration files where an application expects to see a particular configuration file somewhere?
Yeah.
And it has to change from machine to machine.
Yeah, it's a really good question. So we mainly use it just in dev and QA, mostly in dev. It's really early on. And basically we just build the custom container, or we build an image for your environment. So I know that kind of goes against the grain of what they believe in, like we have certain environmental information. But I actually solved the problem recently using Flask, which was pretty cool. And I'll share that with you. Like I can't demo it right now, but it's really cool. So I built this metadata service to kind of handle some of these problems, especially in infrastructure. And you may ask yourself, well, doesn't that sound like DNS? No, because there might be certain kind of data that you need for environment stuff. So the Flask API would reside somewhere either on your data center or in a VPC that's available to all VPCs, so if you have VPC peering going on. Basically, when you make an API request on a particular service like DNS or Puppet, or you want some data on something, it'll return certain data to you depending on the environment you are. So if your bootstrapping container comes up or it has something embedded, you can query the API to grab that relevant data or information that you need. That maybe you can't use DNS for, or there might be like, you can keep some higher data information in there instead if you're using Puppet, instead of keeping it in the higher data directory. You know, there's multiple uses for it, but I think that'll catch on quick when we go into these multiple environments and you have building custom images for certain environments. It kind of goes away from taking a Docker container from here and putting it anywhere. But I think that's really how I'm going to solve it at Finver, is basically creating a metadata service API there. That depending on what VPC or what environment you're on, you're going to get certain data returned to you during runtime.
Did you look at etcd at all for that?
I did. I did look at etcd, and I looked at console, and it's more for like auto-registering, kind of being aware of the environment, which is great for like databases and other web servers, kind of know what's out there. You know, in the gossip protocol, really believe in it. But a lot of times you have static environments, or you have environments that don't really change, or for example, like at Finner, we have multiple VPCs and we have multiple layers of infrastructure in each of those VPCs, and they're all different. And there's certain pieces of data we need here and there. That's where like console or like etcd may not be, or what I found not to be as useful, or it would take some tweaking to get it to that point. Yeah, but I definitely did look at it. I don't always try to reinvent the wheel. I love tools, you know, I love new stuff, but sometimes to meet the requirements of the business, you have to think outside the box and not just give up. Any more questions?
Do you have a separation of QA and prod repositories for now?
Yes.
And how do you promote once you put it in the main repository?
So we do all that through Jenkins. Like I said, the rsync, that's kind of where that comes in. So everything gets built in dev, because everything should be mirrored. Like all the environments should be the same no matter where you're at. You want to stay really consistent, no matter what part of the life cycle you're in. And the only thing that should really be changing all the time is that beta or pre-release repository. You know, you're trying out new things, you're doing new stuff. You may not want to auto-promote things like I was showing in the demo. If you have a lot more user, you have a bigger user base. But yeah, so we have a YAML repository and everything. We just use rsync from Jenkins. And we go, since we have complex security within the VPCs, it's very tight-knit. We have, you know, Jenkins go to one YAML repository, one YAML repository goes to the other, kind of hop around. Sort of thing.
Have you thought of attaching metadata to the RPMs themselves so that you can use them to query them from them?
I think the only thing we had was like version and description. I can't really think of all the other metadata that became really useful. The architecture is kind of like everybody's with x86, and that's kind of really not that important. But like the description can be used for something, especially for security guys. Because when I do the scan, like, what's this RPM? I'm like, yeah, just do a, you know, RPM QA or QPL something RPM or whatever.
Usually the RPM also the issues server like Jira or something like that.
You said Jira?
Jira.
Yeah.
You store those information in RPM for project base, like for auditing, you know, what release notes are, where they were generated from.
Yeah, I mean, you could tie that in if you wanted to. Like for us, like for release notes, since a lot of it is not applications and more middleware components, I mean, not saying you can't use your applications, but most of the stuff we do is middleware. You could eventually like either grab data from Jira's API, which is horrible, or I don't know. You know, there would be some other way to grab some information from somewhere.
Do you find it useful to have them in the RPMs, this kind of menu?
Yeah. Oh yeah. I mean, when I do AMI builds, I attach release notes to it. So like, for example, my my Confluence page, right, will always be called AMI JUL. Whatever the year is, right? Your date command can give you most of that information. You know that every time you do a build, you're going to have those release notes in Confluence are going to be whatever your wiki space name is, whatever your project is, and then the page, which will be AMI July 2014 or whatever. So you can kind of predict things if they're staged and you have friendly URLs. So you can kind of do that too. Like if you don't use API, you can kind of predict some of that stuff. If you keep a standard with the release notes assigned. I mean, I do it with the AMI now with the RPMs, but you can do that, just like a simple date, you know, format the output. That was a really good question, because I don't think anybody pays attention to that kind of information. Yeah, you can do that too, that's a good idea. Any other questions? Sam, you want to say anything before we leave?
Just thanks for speaking, appreciate it.
No
Awesome
problem.
topic. So let's give him a round of applause.